Hello everyone, welcome to SCI-EASE. In the last video, we discussed about the refraction of the light. What do you mean by refraction of light? The bending of the light when the light travels from one medium to another. I have told you about the optically rarer and optically denser medium also. Air is the optically rarer medium and water, glass, they are the optically denser medium. So I have told you that bending takes place. But how much bending that will take place, that I haven't told you. So we will compare the bending of the light in the medium with respect to the speed of the light in vacuum or in air. So what is that? That is the refractive index. So my topic is the refractive index. The definition of refractive index is the refractive index of a medium. The medium may be glass, water, turpentine oil, etc. The refractive index of a medium is defined as the ratio of the speed of the light in vacuum to the speed of light in the medium. In general, the definition is this. So, we depict refractive index by N. We depict it by N. We denote it by N. So, refractive index of the medium means if it is 2, we can write it like this. The medium is 2 and 1 is the air. So, we are telling the speed of the light in the medium with respect to the speed of the light in the vacuum. So, the relationship will be speed of light in vacuum over speed of light in medium, that is the refractive index of that medium. Okay. So, you know, as a speed of light in air is almost equal to speed of light in the vacuum, that I have told you. What is the speed of the light in air or vacuum? It is 3 into 10 to the power 8 meter per second. Okay. So, refractive index of the medium, that can also be defined as the speed of the light in air, okay, which is denoted by C, over the speed of light in the medium, which is denoted by V. So, the expression that can be N is equal to C by V. Okay. So, these are the two expressions by which we can calculate the refractive index of the medium. There is one table given in the book where the refractive index of different substances that is given. Okay, I will show that, and you are not to memorize it. Whenever there is numerical in the exam, the refractive index that will be given to you. Okay, so need not remember the refractive index of different substances. So this is the table you can see. Now how we can calculate? I will take one example. Suppose we are to calculate the refractive index, that is N, where there is speed of, the relationship is speed of light in vacuum, and we are to calculate the speed of the refractive index of glass. Okay, we are to calculate the refractive index of glass. So this is speed of light in vacuum or in air, you can write, over the speed of light in glass. Okay. So here this is 3 into 10 to the power 8 over speed of light in the glass is 2 into 10 to the power 8. So this we will cut it, and what will be the answer? It is 3 by 2, or it is equal to 1.5. So the refractive index of glass with respect to vacuum or air, it is equal to 1.5. So you can see the table also, there it's written that it is 1.5. So whenever the question is there that calculate the refractive index of this substance with respect to air or vacuum, then this expression that is used, okay, and you are to calculate this. You can easily calculate the refractive index. So there is comparison. कंपैरिजन कब होता है कि जब हम कहें कि ये पेन जो है दूसरे पेन से छोटा है या बड़ा है, ये बिल्डिंग ये बड़ी बिल्डिंग है, ये छोटी बिल्डिंग है, या इस बच्चे की हाइट छोटी है या बड़ी है. सो इट इज़ द रेशियो, इट इज़ द कंपैरिजन. ओके, सो this refractive index, it's very important term. You should know how to calculate it, and I have taken this one example. You need not write this glass and vacuum V, and for glass you will write Ng. Okay, in some books it's written like this, NGV, but in some books only Ng is written. When you are to calculate the refractive index of water, then NW. No need to write NWV, because it's understood that the second with which we are comparing the speed of the light, that is the vacuum or the air. So this is very important term, and you should know that in the denser medium the speed of the light, that is lesser. Speed of the light in the denser medium, that is lesser. I have told you that when the ray of the light, it travels from rarer to denser medium, then it will bend towards the normal. This means that the speed is lesser. But when this refracted ray, it will become incident ray, and when it will strike the second phase of the glass slab, it will become the incident ray, and when it will travel from denser to rarer medium, that is from glass to air, then in the air the speed is fast, so the ray will bend away from the normal. That I have already told you. So this thing should be clear to all of you, that in the optically denser medium speed is less, okay, and in the optically rarer medium speed of light, that is more. These things you are to memorize. Same way you can calculate the refractive index of water, that is NW. Okay, you can compare it with the speed of light in vacuum or air, and you can calculate, and it comes out to be 1.33. And the refractive index of air, that is only 1. So you need not memorize it, but these things that can be remembered also. For 2-3 media you can remember that this is the refractive index of air, water or glass. That's it. So with this, my topic refractive index, that is finished. I will come in the next video and take up another topic of this chapter. Till then, thank you very much.